Hi, hello, namaste, welcome back to VSM Math tutorial. So, today we are going to solve few more problems on Laplace transform, my dear students. In the last class, we had discussed about one basic formula, that is Laplace of 1. Today we are going to deal with some more problems, basic problems with respect to Laplace transform. See, we know the definition of Laplace transform, that is Laplace of f of t, that is equal to integral 0 to infinity e power minus st f of t dt. So this is the basic fundamental definition to prove all other results. Now I'll go with one by one. I'll just take Laplace transform of e power at. Very simple exponential Laplace transform. Now you just compare this and t. F of t is nothing but e power at. I'll just replace here. That is integral 0 to infinity e power at e power minus st dt. See, in place of f of t, I just replace e power at e power minus st as it is. Here we know the indices basic power rules. That is e power a into e power b is nothing but e power a plus b. So if I operate for this, what happens? Integral 0 to infinity e power at minus st dt. Now again we know the integral of e power at dt is nothing but e power at by coefficient of t is nothing but a. So what I will do, I will take common term, that is integral 0 to infinity e power minus t I will take common. Why? Because since the limit is infinity, if I take plus t, so after integration I have to substitute t here, infinity here. So e power infinity is again infinite term. Then there is no meaning of solving the problem. Okay? So that's why I am just taking minus t outside. Minus t means it becomes s minus a dt. So again using this formula, so what happens? Integration of this term, that is e power minus t into s minus a divided by what is the coefficient of t, that is minus of s minus a between the limit 0 to infinity. So that is equal to this minus 1 divided by s minus a. I will write outside. Remaining term is this. If I operate infinity for this term, e power minus infinity value is 0. Then it becomes e power 0. E power 0 value is what? 1. Minus into minus plus. Therefore, Laplace of e power at is nothing but 1 divided by s minus a. It's very simple, dear friends, dear students. If we are good in integration, basic integration, we can easily solve this Laplace transform. It is not a big task. Okay? So, practice the steps thoroughly, properly. It is very important thing. In maths, practice is very, very important. Now, this is the basic thing, Laplace of 1, then after Laplace of 1, we have Laplace of at, then I will move on to the some trigonometric term. There are two trigonometric terms, one is sin at and another one is cos at. I will do one problem here, remaining you practice yourself so that you can get the confidence. So what happens? Laplace of cos at I will consider, Laplace of cos at equal to, as usual, integral 0 to infinity e power, first I will write e power minus st, what is f of t, cos at dt. See, we cannot apply integration by parts and other things because both are infinite series here. You cannot apply, means if you apply also it take a lot of time. So instead of applying parts method and other things, what I will do, we have a standard result in integration. What does that result says? We know that, what is that result? Integral e power ax into cos bx dx, that is equal to e power ax divided by a square plus b square a cos bx plus b sin bx. So this is the very, very important result in integration when we have two infinite series. So if I operate this, it is direct. So result I have, I just substitute what is a value, what is b value. Therefore Laplace of cos at, that is equal to integral 0 to infinity. So I already written here, I will just directly go the result, that is ax is there, Here it is e power minus st divided by what is a value? A value is minus s square plus b value is a square here. Okay. Then a is minus s cos a t plus b value is a, that is sin a t. B value is a, therefore it is a sin a t between the limit 0 to infinity. So what happens? 1 by minus s whole square means plus s square plus a square I write outside. So e power minus st minus s cos a t plus a sin a t between the limit 0 to infinity. See, I write always e power minus infinity equal to 0 directly. Why? Because if I bring this to denominator, it becomes e power infinity. What is e power infinity value? Infinity. Anything by infinity is 0. That is why wherever infinity with minus sign is there, you can directly write the answer. So a square plus a square. See, e power minus infinity is 0. 0 into something is 0 minus. If I operate lower limit, e power 0 is what? 1 into minus s cos t value is 0. Cos 0 is what? Cos 0 equal to 1. So it becomes 1. 1 into minus s is minus s. Sin 0 value is what? Sin 0 equal to 0. 0 into something 0. This term becomes 0. So therefore minus s into minus s plus s. So s divided by s square plus a square. So this is Laplace of cos a t. So it is very simple, my dear students. You can easily solve this. Also, I have done cos a t. You have to practice in the home sin a t. So how to find out sin a t? Laplace transform, same procedure. But how I have written for formula e power ax cos bx, you have tried formula for e power ax sin bx dx. That is your work assignment. You have to find out, solve. Same, everything is same. So practice it thoroughly. See, maths, in maths, especially practice is very important. Practice makes man's perfect. There's a code. So practice it well. So I think in the next video we'll come with some more examples. These are only formulae. Based on this formula, we are going to solve some more important examples on Laplace transform. I hope it is very useful for you. Thank you so much.